Thank you, Atley, and thank you everybody for attending today. It's my pleasure to introduce to you some of the decision support tools that were developed within the FIThydro project. I'm the first of a double header presentation with Bendik. So the challenge in FIThydro in terms of supporting decision making in hydropower planning, we're aiming to improve decision making to try and balance the conflict between hydropower and fisheries, to balance the wider energy production demands against environmental objectives, whilst being mindful of the real need to address the impacts of an aging hydropower infrastructure and to upgrade their mitigation. The aim is to provide more detailed, evidence-based decision planning structures that enable best practice to be developed in a wide range of complex regulatory frameworks. So the concept is the decision support system within the FIThydro project integrates a knowledge base. It pulls together our understanding from case studies, of best practice guidance, of some of the solutions available to us in different contexts and different scenarios to address key decisions that enable us to produce best practice projects and best practice decisions when it comes to enhancing and upgrading mitigation of hydropower, particularly for protection of sustainable fish populations. And that's done on a two-pronged approach. Firstly, to develop the knowledge base that underpins and supports decision making, and Bendik will present that within the Wiki. And the second is a structured decision-making protocol. It's a support protocol that's a web-based tool that enables the user to undertake a series of decisions to come up with a best approach to a high-level scoping of a mitigation scenario for a plan or a site. So the web-based tool is a series of tasks the user has to undertake to develop their decisions and provide the evidence to support them. There are three key tasks. The first one is a risk assessment that identifies the hazards posed by a plan or a scheme and the species affected, that is the risk posed, to prioritize those hazards against ecological and environmental objectives and the status of the water bodies affected, and then to identify appropriate mitigation options at a high-level scoping phase from a mitigation measures catalogue, which is housed within the FIThydro Wiki. So the web tool is online, it's open access, anybody can register to use it. It's aimed at all sorts of people involved in the hydropower sector to enable better decision making. The user interface guides the decision maker through a series of steps integrating question and answer catalogues and then matrices of results to review. And the system has a contextual workflow, that is, the user will be asked questions which are only relevant to their system based on the answers they've given at previous steps. Okay, so the first key step is the hazard analysis, and this uses templates for key hazards such as fish passage, hydromorphology, some of the key impacts of hydropower and water bodies, and uses the answers that characterize the fish pass to the hydropower plant to assess what is the hazard for that particular site. The risk is then this combination between the species sensitivity, which is specific to the sensitivity to hydropower impacts, such as the risks posed are this interplay between the hazards and the sensitive species. The second step is to then prioritize those hazards based on the ecological objectives and status of the water bodies affected. So the user is asked questions about WFD status, Habitats Directive, UHULL regulations to identify which hazards are a priority to be addressed and whether or not a water body is failing to meet its objectives. The next step is for an existing plant is to evaluate the existing mitigation measures that are present. And the way to evaluate those is that the user is asked to evaluate them against the specific requirements of a site. So what are the licensing conditions? Does it meet best practice guidance in your area or globally? is it known to be effective? Is there evidence to prove it's effective? Do you consider the hazard to be effectively mitigated? That then leads the decision maker into assessing whether or not further mitigation is required for that specific site and hazard. And the final step in the tool is to be able to then identify at a high level an appropriate list of alternative mitigation measures and a mitigation scenario that could be applied to that plan or that site. The system integrates the catalogue of measures and is fully linked to the FIThydro Wiki, and provides an automated filtering based on context and the characteristics of the site and the hazard being addressed, such that only appropriate and applicable measures are offered to the user to choose from. The user is also provided high-level information about the compatibility of any new measures with existing measures, the effectiveness of that measures in addressing the key challenges in relation to fish passage and hydromorphology, our understanding of the level of certainty of the effectiveness of those measures, and then some of the summary information in relation to the costs of those measures, both in terms of financial costs, any power loss in terms of implementing those measures, and then the types of maintenance that might be required for those measures. And in the DSS, this is high-level information, but the DSS system is fully linked to the wiki, where these evidence base and knowledge is dealt with in more detail and provides more evidence for the decision makers to use to underpin their choices. So the key benefit of the tool as it's been developed is we recognise that all hydropower plants face similar problems, but all have a unique situation. So the structured decision approach is flexible and works as a scoping tool within the decision-making process. It's widely applicable and adaptable to different situations. We recognise that resources are limited, and therefore we need to be able to prioritise hazards, mitigation measures, and project proposals. And we know that decisions are often limited by evidence, and that is why the tool is underpinned by our knowledge base within the wiki that provide the decision makers with the information with which to make their decisions in this structured approach. So I will now say thank you very much and hand over to my colleague Bendik, who will talk you through the FIThydro Wiki.
Yes, hello. I'm Bendik Hansen from SINTEF Energy, and I will give you a brief introduction to the wiki. So the FIThydro Wiki.
Bendik,
Yeah.
Bendik, we're seeing the wrong screen. You're seeing your presenter view.
I thought I shared my, sorry about that. Let me try it again. Share screen. I'll put this one then. Share screen. Share. And now do you see the presentation?
Yes, that's fine. Thank you, Bendik.
Yes. So the wiki is an open access online platform, which means that anyone can go there and read everything that's on it. And it tries to give a systematic presentation of the outputs from the FIThydro project. And this includes a catalog of solutions, methods, tools, and devices for fish-friendly hydropower, and also descriptions of the FIThydro test cases, and an overview of other FIThydro outputs, such as the policy and public acceptance studies, and the decision support system, of course. So instead of showing you a bunch of pictures from the wiki, I will go online and demonstrate it to you. Hopefully that works. You see it now? Do you see the website?
Yeah, we do see it.
Great. So this is how it looks when you go there, and it has a brief introduction to the project and to the wiki. If you scroll down a bit, you can see how the structure is. So like was mentioned earlier, we have divided the challenges into 5 categories, which are habitat, environmental flow, sediment, and downstream and upstream fish migration. And in each of these categories, we have a list of measures that can be used to fix them. For these measures, which we call solutions, each one has a description of it and how to implement it. And it has a classification table, which is what Richard was just touching on, and I will get back to in a second. And it has links to relevant methods, tools, and devices that can be useful for actually implementing this measure, and links to the relevant test cases where it was either used or could have been relevant. So at the very bottom, we see these 5 categories, and you can expand the list to see which measures exist in them. So if we go to one of these, for example, the habitat one, it has an introduction to this challenge, what issues can be related to habitat and hydropower. And then it has all the different measures that we have written about. So we will go to one of these measures, placement of spawning gravel in the river. And then you can read about this measure on a fairly high level. It doesn't give you enough detail to implement it, but it gives you enough to start. So it has an introduction and some description about implementation in different stages of the process. And if you scroll down, you will find the links to the methods, tools, and devices that can be useful for implementing this solution, as well as test cases from the FIThydro project, which are either relevant or where it was actually applied. If you scroll even further down, you will see the classification table, which tells you about different aspects of the solution, such as where it can be applied, what challenges it addresses, and its technology readiness level. From here, we can move on to one of the methods, tools, and devices, for example, Telemark. Here you see a brief description of this software. So this is a tool, defined as a tool. And you will find, likewise, like in the solution article, you will find a list of solutions that this is relevant for, and test cases where it could have been relevant or where it was actually applied. Then we can move on to a test case article to see how they look. In the test case article, you will find a description of the study area. For more information, you can find a more detailed report in the top right corner. It will describe what challenges are there and what topics were investigated in the project. It will also have the results from this from the project here. So you can read about how the solution might have impacted or performed fish migration or similar. At the sidebar on the left, you will find links to many relevant areas of the wiki. For example, you can go to the different categories of challenges or solutions. You can go to read about the DSS or the test cases and the public policy, public acceptance, and you can find a list of costs for different solutions. And you can find a list of the innovative technologies from these projects. So here we have technologies that we either developed or enhanced in the project. So that concludes the brief tour of the wiki. I'll now go back to my presentation. And this wiki, it can be used to gain knowledge about the challenges and solutions related to hydropower and fish. And it could be suitable as a rough screening tool to find the appropriate measures. And of course, it is linked closely to the DSS. So the user of the DSS gets certain recommendations and they can go and read more about it on the wiki. The structure of the wiki, it's like the Wikipedia structure, uses the same foundation. It allows for very easy navigation between topics. And it's a living document, which means it can be updated and enhanced, expanded when new technologies come out or things change. And this can be done by approved users. Not anyone, but people who are approved. It's easy to access, it's easy to look up and link to, easy to share, which can make it easier to communicate, for example, between non-scientific policymakers or the general public. It's easily available to everyone. So this concludes my presentation. of the wiki, a short introduction. Please feel free to go and visit it at fithydro.wiki. Thank you.